Okay, so this is a unit circle, and all that really means is that this circle has a radius of 1, and we will be going a little bit deeper into the angles and cosine and sine values that are inside of this circle. Yeah. So the unit circle begins at the x-axis and rotates counterclockwise around back to the x-axis. So we are going to be looking at the first 4 angles that I've drawn out here. Okay, so this first angle is 0 because it's where we're starting from. Up here, pi over 2. Over here is pi. And then we have 3 pi over 2. Then we finish with 2 pi. So what this is telling us is that the entire unit circle is the equivalent of 2 pi. Okay, so these 4 angles are in radians, not degrees, and basically that just means it has pi in it. And so this angle is pi over 2, which is basically saying it is half of pi. Which makes sense because if you look over here, half of the circle is pi. So if we look at this quarter of the circle, it's saying that it's half of pi, which it is. And so if this one is half of pi, then it would make sense that this one is 3 pi over 2 because there's 3 quarters so far. And all of this adds back up to 2 pi. Okay, so as you can see, we have cut the quarters in half. So now we have doubled the amount that we have cut the quarter. So it goes from pi over 2 to pi over 4. Since we doubled the amount, it was cut. And then, so the first one is pi over 4. And then since there are 3 of those sections, the next one is 3 pi over 4. And then 5 pi over 4, and then 7 pi over 4. And what we did was we cut all of the quarters directly in half. Okay, so now if pi over 2 is a quarter, and then we take a third of that quarter, we get pi over 6. So basically, we have pi over 6 here, and then we have 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, finally we have pi over 3, which is larger than pi over 6 because we are dividing by a smaller number, so the leftover amount will be larger. And so if you reflect pi over 3 over the y-axis, we have 2 pi over 3, and we reflect it over the x-axis, 4 pi over 3, and reflect it back over the y-axis, finishing with 5 pi over 3. Okay, so now we're going to look at the angles that each of these points shows us. And they'll be in the form of cosine theta, sine theta. And so this unit circle will help us by showing us all the different angles that each of these are on. Okay, so these are the 4 points for the axis. So here we have 1, 0, because remember the radius is 1 and the origin is right here, so it is 1, 0. And now up here we have 0, 1. because the radius again is 1 from the origin. And then we have -1, 0, and 0, -1. Okay, so what these angles give us is our cosine and sine values. And what that's telling us is that the first part of the coordinate is the cosine value, and the second is the sine value. So for example, this 1 would be the cosine value and 0 would be the sine value. Okay, so the three numbers we will be using to fill in all of the coordinates will be 1/2, which is the smallest, √2/2, which is the middle one, and √3/2, which is the biggest. And we'll be using these three numbers to fill in the points on the entire unit circle. Okay, I filled out these three x values of these points, and let's not forget that √3/2 is our largest of these numbers, and I've put that with pi/6 because if we look right here, from here down to our x-axis, pi/6 has the longest distance, so we give it the largest number. And so that means pi/4 has the middle distance, so we have √2/2, and then that leaves pi/3 with the smallest distance of 1/2. Okay, so now I've filled out the y values. And it's the same sort of idea for pi/6. So right here, it's at the lowest point from the y-axis. So this one's the lowest, so it gets 1/2. And again, this one's in the middle, so it has √2/2 because it is the middle height. And then pi/3 is the highest point out of those three, so it gets √3/2 for its y value because it has the highest one. Okay, so all of these numbers, all of those coordinates follow the same sort of idea as I demonstrated with the first quadrant. And the only thing that's different is that there might be negative values involved. So here's the first quadrant, the second, the third, and then the fourth. In the first quadrant, everything is positive because everything is on the positive side of the x-axis and the positive side of the y-axis. But in the second quadrant, however, there is negative x values because we go left where x is negative. And so there's negative signs in front of all of the x values for the x coordinates. And in the third quadrant, it is both negative on the x value and the y value. So there's negative signs in front of both of them. And in the fourth quadrant, only the y value is negative. So there's only a negative sign in front of the y values. Okay, so far we have only talked in the terms of radian, which is everything with the pi. But each of these degrees have a number value. Each of these angles has a number value in degrees. So the first one is 30, then 45, then 60, and then 90. Then we have 120, 135, 150, and 180. Then 210, 225, 240, 270, 300, 315, 330, and 360. Notice how 0 and 360 and 0 and 2 pi are in the same place. That is because the circle begins and ends in the same place. Okay, so the way we apply the unit circle to math is if someone asks you what the radian and degree for the value of cosine of 1/2, you would say pi over 3 and 60 and 300 degrees and 5 pi over 3. So that's how you can use the cosine and sine values in math using your unit circle. Thank you so much for watching. That is the unit circle breakdown.